Hello students, today we discuss about UV spectroscopy. In previous class I explained you about spectroscopic techniques. So what is spectroscopy? So spectroscopy is the study of interaction of matter and electromagnetic radiation. So it is a branch of science that deals with the study of interaction of matter with light. So and also there is an interaction between matter and the electromagnetic radiation. What is electromagnetic radiation? So, this electromagnetic radiation consists of discrete packages of energy which are called as photons. So, they produce electromagnetic spectrum. The photon consists of oscillating electric field and an oscillating magnetic field which are perpendicular to each other. So, this electromagnetic spectrum ranges from very short wavelength to very long wavelength. So, in this electromagnetic spectrum, we need to know what is frequency and what is wavelength. So, frequency is measured in nu. It is defined as number of times electric field radiations oscillates in 1 second. So, we already know that the unit of frequency is hertz. And what is wavelength? Lambda. It is the distance between two nearest parts of the wave in a same phase. So that is difference between two nearest crest and trough. This is electromagnetic radiation and the electromagnetic spectrum. This one I explained in the class itself. So like how that violet that prism, it shows that VIBGAI are colors: violet, indigo, blue, green, yellow, orange and red. UV visible spectroscopy. So what is UV visible spectroscopy? So this UV and visible spectroscopy involves the absorption of radiations by the substances in the UV and visible regions. So the absorption of energy leads to promotion of electrons to higher energy level. The extent of absorption depends on the wavelength or frequency of radiations and the structure of molecule. So that means it involves absorption of radiations by the substance in the UV and visible region. So here two regions are there, UV region and visible region. So in UV spectrum, it is around 200 to 400 nanometer, and visible spectrum it is 400 to 800 nanometer. So what is the principle of this UV visible spectroscopy? So that means here absorption of radiations by the substances in the UV and visible regions. So and it here anti-bonding orbitals. So the orbitals which do not involve in bonding. So there is a transition, electronic transitions is there in UV visible spectrum. So these excitations, like some various excitations are possible. So and there are various absorptions corresponding to these transitions. So these transitions like from sigma bonding to sigma acidic bonding. So like many levels are there: bonding, non-bonding and anti-bonding. And the possible electronic transitions, sigma to sigma star, pi to pi star, n to sigma star and n to pi star, sigma to pi star and pi to sigma star. These are the transitions. So the principle of UV visible spectroscopy is related to interaction of light with matter, and light is absorbed by the matter. The result is an increase in the energy content of the atoms or molecules. And here ultraviolet visible radiations are absorbed. This results in the excitation of the electrons from the ground state towards higher energy state. So this molecule containing pi electrons or non-bonding electrons can absorb energy in the form of ultraviolet visible light to excite these electrons to higher anti-bonding molecular orbit. So there is a pi to pi star, n to pi star, sigma to sigma star and n to sigma star, and they can be ordered as sigma to sigma star, n to sigma star, pi to pi star, and n to pi star. So the absorption of ultraviolet light by a chemical compound will produce a distinct spectrum that aids in the identification of the compound. So this is the principle of UV visible spectroscopy. In UV visible spectroscopy, we are having two concepts, chromophores and auxochromes. So what are chromophore? What is chromophore? The part of a molecule responsible for imparting color are called as chromophores. These chromophores are having functional groups containing multiple bonds capable of absorbing radiations above 200 nanometer. That means in the UV region. So that's n to pi star and pi to pi star transitions. What is auxochrome? The functional group attached to a chromophore which modifies the ability of the chromophore to absorb light, altering the wavelength or intensity of radiation. So that means auxochromes are the saturated groups with lone pair of electron, that means non-bonded electrons. Attachment of these auxochrome to the chromophore alter the wavelength and intensity of absorption. So depending upon this, we are having four concepts: bathochromic shift, hypsochromic shift, hyperchromic effect, and hypochromic effect. So what is bathochromic shift? The extended conjugation and auxochrome may shift the absorptions to longer wavelength. So this is called bathochromic shift. So what is hypsochromic shift? A shift of absorption lambda maximum to shorter wavelength. So it's called hypsochromic effect. So this hypsochromic effect is called as blue shift, and bathochromic shift is called as red shift. So this is the shift and effects. Blue shift is hypsochromic effect, and red shift is bathochromic shift. So and the greater absorption it is hyperchromic shift, and lower absorption it is hypochromic shift. What are the applications of UV visible spectroscopy? So they can be used for determination of impurities in organic molecules, and by measuring the absorptions at a specific wavelength, the impurities can be detected. So and also the structure and elucidation of organic compounds. Along with this UV visible spectroscopy can be used. Detection of functional groups, presence or absence of chromophores can be detected. Extent of conjugation in polyenes can be estimated. Identification of conjugated and non-conjugated compounds, and also identification of the unknown compound by comparing its spectrum with the spectra of known compounds. Examination of polynuclear hydrocarbons, elucidation of structure of vitamin A and vitamin K, equatorial and axial conformations can be distinguished. So and it is a UV spectroscopy is having many applications. So many drugs are either in the form of raw material or in the form of formulation. So they can be assayed and we can find out the molecular weight of compounds. So and also this UV spectrometer may be used as a detector for HPLC. So in your examination they ask for 10 marks question. Discuss the working principle and applications of UV visible spectroscopy.